I'm very pleased to present Andrei Chis today, a member of the FINC team. He will be telling us today about moldable analysis using Moose, which is a modeling and analysis platform. And without any further ado, I'll pass straight over to Andrei. You have to start screen sharing again. I just killed it.
Yes, so hello everybody. Give me a second to share the screen again. You should be able to see my screen now. Super. Hello everybody, I'm Andrei Chis. I'm from FINC. Last time, or 2 weeks ago, Tudor Gârba, a colleague of mine, was also doing a course, and he talked about this idea of moldable development. And he showed you a bit Glamorous Toolkit and the tools, and what does it mean to do moldable development in Glamorous Toolkit. And today, I will pick up where he left, and we are going to look more at how to do moldable analysis. And there, the idea is going to be that we start from this remark that also Tudor, you heard it before in Tudor's presentation, that any boundary in software is arbitrary. And we are going to try to see what that means with regard to software analysis tools. Because often when we are using tools to do various kinds of software analysis, they tend to be other tools. So we have the IDE, we have one tool, then another tool, then another tool. There seem to be a lot of boundaries in this space. Today we're going to try to see what does it mean if we remove some of those boundaries. How could a tool for analyzing software look like? And for that, we are going to use Moose. Moose is a platform for software analysis that comes with various types of components. Most of them are integrated within GT, so you do not need to load anything else for this. And the idea in Moose, and also in GT, is that we do not provide a set of predefined analysis that you can just download and use. So there are no set of large set of standard types of analysis, already made analysis that you just download and use. And we don't focus on that because the problems that really bring value in a software system are often very, very contextual. What most of the times will happen is that you go to the internet, you download an analysis tool, you apply it on your system, you get some results, and then you wonder, why aren't these results useful for me? Why aren't they solving my problem? And more often than not, it happens because those tools do not capture your context, do not capture what's actually important and specific for your system, because those tools focus on what's common among all software systems written in a language. And usually that part is the language part. They fail to capture things that are very, very, very specific for your software system. That's why, as an analogy, you don't download unit tests from the internet for your system. You write your unit tests because they capture what's important. If you could download them from the internet, that would be awesome, but nobody else from the internet knows the context in which your system lives. So to address that, in Moose, the focus is on providing so-called engines. So like tools for building tools. Because even if we cannot predict exactly the concrete analysis that you need to do on your system, what we can predict quite reliably until now is the types of analysis that you like to do. So for example, you have data. The source code of your system is just one type of data about your system, but you also have others. There are, for example, log files. Everybody has log files. Or you can gather runtime data by instrumenting your code. You always have now configuration files. Maybe you have deployment files. Maybe you have code or configurations for how your cloud or how your application is deployed to the cloud. All these are data. So at first, the focus is on building importers. Often there are, or in some cases, you'll find already made importer if the data that you want to load is a standard one. But often it will happen that the data that you want to import is not really a standard one. Maybe you have some custom logs. Maybe you want to import a very custom language or a domain-specific language. So for that, a focus in GT is on these importers, engines for building parsers through which you can import the data into the image. And once you have your parser that reads the data and brings it into the image, it needs to be stored somewhere. So for that, another set of engines is focused on building models. In this case, object-oriented models for representing various kinds of data. The one that we are going to look at in details today is a model called FAMIX. FAMIX mostly focuses on modeling source code, tries to be a language-independent object model for modeling source code. So as you'll see, it has entities, for example, for classes, methods, packages, and modeling the connections between them. And FAMIX doesn't try to be a very fine-grained model. So it doesn't go all the way to the level of the AST. So you'll not find like this is a switch statement, this is a case or if. It mostly focuses on the higher level components of your system and the relationship between them. Usually these are methods, attributes, classes, packages. And of course, there are engines for you to build other kind of models if you need to. And then once you have your model, next set of engines is for building various kinds of analysis. The ones that we're going to look today is for querying and visualizing. Those are the most common things you'll do after you load a model. You like to find some data in your model, and then you like to visualize it in some way to make sense of it. And so by focusing on engines, it means that you can import your own very specific custom data, model it the way you want, and then write custom analysis and visualizations for you to make sense of that data. And today, we are going to use for that, we're going to analyze a Java system. The Java system is called ArgoUML. It's more or less an application for drawing UML diagrams, as the name suggests. So it's in Java, and first thing we need to do in order to be able to analyze it is to get our hands on one of these FAMIX models. For Java, as well as for other languages like C or C++, the way we do it is we need an external importer. So an external tool that we run on the source code of the system, and that creates us this FAMIX model that we can then import into GT. For Java, the tool is called, I guess, JDT2FAMIX, but there are also a few others. And it's been written in Java. Our case JDT2FAMIX uses Eclipse, so the Eclipse JDT parser, mostly because that's a very nice parser for Java code, and we can delegate all the parsing and building of the model to it. We are just then exporting it and then importing it into Moose or NGT. For now, you will not have to run that tool. We already did it. We already run it on ArgoUML, created the model. All you'll have to do is download that model, which comes into an archive, and then import it into the image. I already run these snippets because otherwise it might take a few minutes, but we can inspect the results. So the first one just downloads an archive from the internet, so from our tutorials, containing the source code of ArgoUML, so I can inspect and I get an inspector. Now I'm just in the playground here. And if we look further, so we have ArgoUML. Here we have the source code, if you want to look into it. And here we have something called ArgoUML 034.msc. The .msc is a format for storing Moose models or FAMIX models. We can go into it, look at how it looks like. It's mostly a model that optimizes for storing highly connected graphs, as the model of the software system is a graph. But we don't have to care about this. You can think of it another model as another format as JSON or XML. Just this one is called MSE. You rarely have to go into the details of it. And the next snippet is going to be the one that if you run, it will load this MSE file and create a FAMIX model into the image. This usually will take 1 or 2 minutes to run. The last snippet here is just for this presentation, and we are storing this model in a global place so that we can reuse it in our other slides, because we don't want to create it for every slide. Okay, next, let's look a bit at what do we have in this model for this ArgoUML Java system. So when we inspect a model, a FAMIX model, what we get is an object. So we're still in an object inspector. This object is called the Moose model, and it has different views. The first view, maybe the most important, gives us an overview of what's in this model. And in the next minutes, we're just going to slowly go a bit through, or faster through, the model, explore it a bit and see what's here. And then look at what kind of analysis or how can we use this model once we have it. Let's see what do we have here. We can see we have maybe methods. So this system has 23,000 methods. We have maybe classes. This has 2,300 classes. And notice that we have maybe all model classes and here all classes. Often when we import a system, we also want to take into account all its dependencies. So these are all the classes that are within the system and all of its dependencies. And everything that's mostly with model are all the classes that are only within the system itself. So ignoring all the classes from, for example, from libraries. We also have like attributes, annotations, exceptions, namespaces, so different kind of things. And okay, once we have this, it's not useful just to look at it. What we can do next is try to dive in this model and explore it a bit, explore some of the things that we might be interested in. Let's say we want to look at namespaces. We could select them, double click, then we get a new pane. That gives us, in this case, the list of all namespaces from this project. So you can, namespace being a package. As Famix is a language independent, sometimes the terminology doesn't match the terminology in Java 100%, because these concepts are meant to be more language independent. So in this case, a namespace captures the notion of a package in Java. We can look, maybe we find a package that we're interested in. Let's say I want to look at the UI package. I could select it, and then I get, okay, some information, like I can see this package has 84 classes. Okay. If I select it, I get the list of classes. So notice now I'm looking at the Famix class group, just the object for modeling a group of classes. I can look at it as a list, or maybe I can look at it as a hierarchy. So now I have a view that shows me all the classes by grouping them by hierarchy. So I can see that in this UI, there are not that many hierarchies. There's mostly one here, a bigger one, and a few other small ones. Another thing I could do is maybe navigate a bit more through this. Maybe I want to look at the class. Now I can see the class, I can see the source code. I could also see some other views. This is a blueprint, so it just shows me the methods in the class by grouping them by what they are. So I have some initializer, part of the interface, implementation, attributes. Just a different way to look at this class. I could also look at methods. Maybe these are the methods, and yeah, maybe I find one method and look at its source code. This is just a way that I can navigate through this model. And until now, I just navigated through this model by clicking here through the data. This is one way to do it, but this is in a way quite limiting. You can only navigate to what the tool already allows you to do. You cannot say, okay, now I want to do something else, to go to some other object. How do I do that? For that, since this is an object inspector, you always have the option to spawn like an editor or a playground and use code also to navigate. And this is particularly useful when what we want to do is actually query data. Because, yeah, maybe I just want some of these methods. Let's say I have here 36 methods, and what I would like to do is find only the methods that have more than 50 lines of code, just for the fast query. How would I do? I would go here, I would look at everyone, each method, and then count the lines of code. Never. I would write a query. First, to write this query, I need to get all this list of methods from my Famix class. And how do I do that? One way would be to go to the meta, which shows me an editor on this class, on an editor on the class of this object, look for it, but it will take me a while to find it. A better way is to like right-click here on the name of the label, and then the tool offers a context menu that says, browse me the method that implements this navigation here. So every time you see something in the navigation view and you want to know how do I obtain this programmatically, you could use this menu, and this one says, hey, it's the moose group method. So all I have to do is come here and call the moose group method, and then I get the same list of 36 classes. So now I know how to do this programmatically. Okay, I have the group, now let's select. But what to select? So I will get every method, and now I want to get lines of code and check if it's greater than 50. Now how do I do that? Okay, maybe I have no idea what message do I need to send to maybe it's line of code, lock, there can be many names for that. Again, we can quickly check. If we go to any entity, we have properties. And in properties, we'll have all all those that are available for this entity. And I see here there should be number of lines of code. Perfect. It's 28. And if I double click on it, select it, I get back the method that actually implements this metric. So in this case, it's number of lines of code. Super. Now I know this. I can go back and say each number of lines of code greater than 50. And now I get two methods in this class that are over 50. So now every time you have an entity, you can continue the navigation by querying, not necessarily by clicking. So the tool doesn't say only navigate here by selecting the data that you have in the views. It can only say, hey, get a playground and do whatever you want on this. Query the data the way you want it to. Okay, this was a very short introduction to the FMX model, what's in here, and how can we navigate through it. Next, let's write actually a more useful type of visualization. And for that, we are going to focus on deprecated classes, as they are very common, and it's a nice example to introduce this idea of writing analysis and writing more custom analysis. Before we start, let's see a question. So imagine that you want to reason about deprecated classes. You are a developer in a company that has a system that has around 2,300 classes. You know maybe that 40 of those, 30, 40 of those classes are deprecated, and somebody comes to you and says, hey, we have these deprecated classes. We maybe want to remove them in the future, but we have no idea if this is a big problem, if this is a small problem, so no idea. And what they ask you to do is take some time and just figure out how big the problem is. So not remove the deprecated classes, not understand how they are every time used. Just what you need to do is take some time to figure out, is this problem big? How many classes do I have? Who uses them? How are they using them? And what the other person would like for you to tell is how much time would you need to do this kind of estimation, this kind of analysis. So not the removal, just the estimation of how hard the problem of removing them is. What do you think? I mean, if there are 40, you would need to go through them, find them first, then maybe go through them. Once you have them, look at how they are used, from where they are used, just get an understanding of all this information. What would be, how much time would you say you would need, or how much time would you ask for to do this? Any thoughts, guesses, or? Everybody's quiet. Okay, who knows how much time, but let's see how could we do this here. So what do we need? Ideally, we need classes. So I have here all my model classes, and from all these classes, let's say that we need to find the ones that are deprecated. Again, we could scroll, maybe even we could do some search, but most interesting would be to write a query. So we summon an editor, a playground, and then let's say we want to select, because I want to get only deprecated classes. I want to select only those that are dated with deprecated. So what do I do now? I'm writing a query to filter this group of classes only based on those that are annotated with this deprecated annotation. If I inspect this, I get 25. Hooray! So far, so good. I can even check. So always, if you write a query, it's also good to double check that actually what it returns makes sense. So indeed, I have the deprecated annotation here. Maybe look at another one, deprecated annotation here. And indeed, these ones seem to be deprecated classes. But are they used or are they not used? How could we find that out? If we maybe look at this class here, does this have something? We can see that it has something called client types and provider types. Client types and provider types. These are two notions in a FMX model. The provider types are my providers for all the classes that I am using. And the client types are my clients, all the classes or types that are using me in some way. And what we can do then is come back to our query and refine it a bit. So we can say, give us all classes that are annotated. And maybe we want to say, and each we are interested in client types. So we want deprecated classes that are not used. So is empty. Now we can get all the classes that are deprecated and have no clients. If the list is 25, has 25 classes, we are done with this. Let's run. 14. Okay, not ideal, but still 14 classes we could just remove. These are easy. Nobody's using them. We can remove them and be done with it. But what about the next? Then let's say it's not empty. This should give us the opposite. Now we get 11 classes. Okay. For these ones, now maybe the time that we'll have to select them. Let's say maybe I'm like, look at this. Once I have it, I may want to go and find its client type, see who's using it, and then maybe go through this list and do the same. And then, but this will take some time. And also here, if I select client types, what's interesting is that one client type is this critic OCL evaluator. And if I go back, critic OCL evaluator is also deprecated. So we have a deprecated class calling another deprecated class. So if all these classes call each other, then I can also remove them. Just finding all this information out might take a while. So what we can do actually is build a view. We could try to create a visualization to see a bit the connections between these deprecated classes and their clients. And we can do that also live directly in the playground associated with this class, with this group of classes. So let's do that. GT also comes with the engine called Mondrian, and is mostly for building graph-like visualizations. So I instantiate it by saying Mondrian new, then I want a view that has some nodes. And in these nodes, I'm going to put, let's say, what do we put? We put self. So self is the class group. And I want from self all the client types of all these classes. So if I send client types to a class, I will get them. But I want to collect the client types for all the classes. So I want to also flat collect, so just merge all these collections into a single collection. Client types. I could actually also select this and inspect it live, because I can. And I get a list, it has 35. But if you look closer, you notice that some are duplicated. Okay, can be that some of these classes have the same clients. So in this case, maybe what I want to do is also say as set. So just give me a set that doesn't contain any duplicates. And now indeed 35 and no more duplicates. Next, maybe let's put a layout, which can be a grid, and then let's return a view. Okay, so far so good, but yeah, not the best view, because first I cannot distinguish which are the deprecated classes. So let's solve that. For every node, I could have a shape. And this shape will tell me how to render that class. So let's say we want to render the shapes as circles. So first we need a BL element, so a graphical component. Let's say we set the size to 5 at 5. Then we say, or maybe, what should we put? Geometry. So that it's a circle. Last but not least, let's put the background to be a color. And we can put this color to be maybe red for classes that are deprecated. So we'll have to say each is created with deprecated. And what did I forget? Okay, I have one more here. If this is true, and I want to do something if this is false. If this is true, maybe I want to put color red, and if it's false, I want to put color gray. Looks okay. And of course, I forgot, it even tells me I forgot to add the separator for the parameter of the block. And now what did I do? of course, I forgot also to put here a semicolon because shape and width are two different methods. And now I'm getting the view back. And now I see, okay, these are my deprecated classes, but I still don't have edges. And I really like edges between a class and and its clients. So let's add some edges. And here I want to connect every class with all its clients. Connect from all. It's a utility method that is in Mondrian, and I will say connect from all, and I will just copy client types. So now we will create the edge between every class and all its client types. So far so good, but maybe the layout is terrible, so let's use a force layout. And now we get a different view. So we spend like 5 minutes doing these queries and building these views, and now we get a rather different way to look at this data. What we can see is that these two classes are calling each other, so I could just remove them. This is an interesting case, because here, seems that this is one class that uses two deprecated classes. So if I just understand this one, I should be able to remove both of them. And now, this is also not just a static view. If I click, I can navigate to the actual class. Maybe now it's the time when I can start reading code. Before, I didn't. What I started with is a model, I created a query, I was refining that query, then we are building a view, again, iteratively seeing what we want to see in this view, and then getting the visualization, and then using this visualization in order to navigate and make sense of the actual data. Again, all I'm doing is in the inspector, and I can move freely between the tools and the kinds of analysis I want to do. It's not like now I'm just doing a visualization and nothing else, or now I'm just writing a query and nothing else. And interestingly enough, here we could also continue in different ways. You saw last week that, so I said before that in Moose, in the Famix model, there is no information about so the internals of a method. So the fact that I have a final or a for loop, or maybe nil, this checks for nil, it's not part of the Famix model. And let's say, just to see how it could look like, that I would like to do next is find out what are all the places that null is referenced in this method, or maybe what are all the ifs that check for null. What I could do is, since it's just source code, I could take a Java parser. So this is a parser available in GT. And I could say I want to parse the source text of this class. And now if I run this, what I get back is an actual AST. So this is my AST of the class. So maybe I can select superclass, and that this is the superclass type node that represents this class here. And if I go and find something that has null, okay, this seems to have null. I can see that this is of type of Java null node. And let's say that next, what I want to do is write a very, very quick query to give me all the nodes, all the Java null nodes from this method. Okay, we need to put them in somewhere. I will just order collection new. Now there is a method, I think it's called all nodes of type do, exactly, all nodes of type Java null node, do nodes add node. And then I want to inspect the nodes. Now I wrote a small query, this time traversing an AST to give me some part of that AST. So in this case, all the null nodes in the AST. So I get 87. So null is referenced 87 times here. And if I go to 1, I can see, okay, this is the null that's described here. Maybe I have other nulls. Okay, this is the null actually that's in an assert. Interesting. So now I could maybe refine this to say, okay, now just give me all the nulls that are in if statements, for example. Just the most important aspect is that here we said, okay, now we have a class and we want to continue our exploration. This time by looking and analyzing the ST. And we can again do that within the same workflow. We don't have to switch to another tool, change context, because again, tool between boundaries don't have to be there. We should be able to move freely between them as we need to do, as the data that we have requires us to do. or the analysis that we want requires us to do that. Coming back to this view, this view here is quite generic. If we look at the code and at the view, we could take this view and apply it on any other Java system. There will not be a big difference between applying this on ArgoUML or another system. However, this view is still useful. It still gives us an overview, but maybe we can even make it more useful. Let's spend another 5 minutes and make this view a bit more concrete. So maybe I have more information in this view. For example, in ArgoUML, we have two main components. One is the model and one is the UI for a UML diagram. So how you model a UML diagram and how do you visualize it. And for that, I will switch to another slide. So here we have a bit the same analysis. Only difference is that this time we are adding a border through all the classes that are part of UI. So if a class that it's in the UI package or part of the UI component, it will have the blue border. Let's see what happens. Super. So now we can actually see more interesting things. And this view is very specific to this software system. And what we can see now is that the deprecations are actually not cross-cutting. So we either have UI classes or they have model classes, which is perfect. So it means that to remove maybe this one, we just have to look at the model. And to remove the big one, okay, here we'll have to look at the UI, but we don't have to switch between these two. Even more useful is I have no idea how big these classes are. Okay, I can see classes, but how big are they? How many are there? How many methods there are there? It's like, So let's extend a bit this view now by using as a size for each node, let's say the number of methods, or what was I using? Yes, the number of methods. For that, we have another view. Again, this view changes just a bit. Now we add a size, and we change a bit the layout to take into account the different sizes. And if we run, whoa, now we get a different story here. All of a sudden, we can see that, so look at this. These were two deprecated classes calling two deprecated classes called from the same method. However, this is huge. Can I select it? It has 64 methods. So maybe this will be a lot of work, who knows? But this is a huge deprecated class called from another huge deprecated, from another huge class. This is a huge deprecated class that's being used in the system. Interesting. Now we get some more information. Just now, I switched slides. Just now, the next question that comes to mind is, okay, these are huge classes. It actually has 64 methods, but how many of them are actually used within the system? Maybe out of the 64, just a few are using this, or maybe all. Now, let's spend just a few more minutes. I will not write the code because we don't have time. We will just use it here. The only thing that this changes is that for each class now, instead of just showing a circle, we show a composite shape that contains all the methods. And we just filter those methods that are actually used from deprecated classes. And now we get a completely different story. Remember that huge class? It's this one. So from that huge class that had 64 methods, only 2 of them are using a few other deprecated methods. So now we reduced the scope of our problem, in this case, by 1 order of magnitude. We just need to look at these 2. So here and this one seem to be a bit more problematic. And let's say that we like to start with this one, to remove this deprecated class. Which method should we take first? Because they all seem identical, but maybe some of them are used more than others. Maybe. Let's find that out. So this is another view, most complex until 1, and all this does is also adds a size for the methods based on how much they are used. So I can see now that these ones, this and this, are the ones that are most used in the deprecated method. And now is the place where I could go look at the code, look at how they are used, and see how I can remove them. Actually, turns this is the constructor of this class. Interesting. And makes sense. If people are using the deprecated class, they have to instantiate it in this case. Coming back, this is our analysis. Yeah, it's still a bigger one, but it still fits on a screen. And in a normal setup, if you're familiar with this, it will take, it took me like half an hour to create all of this. And after half an hour, I have a custom tool that I can use to reason about my problem. My problem in this case being deprecated classes. And now using this tool, it will be the place where I can actually go and read the code. I will not read code in order to do the job of this tool or of these queries in order to find reading code in order to find what code to read. Instead, I can query, visualize, do an analysis to help me find the interesting places that I need to focus on. Okay, one more example. Until now, we are looking just at code. However, there are other interesting things about the software system. If we go back, if we go to the next slide, let's inspect a bit our model. So if we inspect our model and go to the root folder and go to the source, let's choose maybe Java, we see that we have a build file. And this build file is actually it's a Java system, so it's the end file to build the classes, to compile the classes or test the classes in this system. This is interesting. Now my question is, I have this build, okay, every one of these has a build, okay, how are these build files structured or structured within these folders? Let's say that's what I would like to reason about. Is it just one level? Are there multiple levels of them? Are they nested? How are they structured? Because here, for example, I can see that here it's a nesting and it's a big nesting. And now it's here. I'm curious just, is there a bigger nesting or how are these build files structured within the system? For that, again, I could do it manually or I could write a query. First, I'm getting all those files from the model. It's a list in this case of 36. We get also the directories containing them. And then we can build a view. That's a simple view. It only shows them to me as a tree. And voila, we can immediately see that now we have two levels of this has a two-level project. So there's going to be one, and then this one is the ArgoUML that contains more. And if we look at this, we can see that this is CPP. So I guess the E should be some Java. Okay, so this one seems to be for individual languages, and this is the core of the system. However, the interesting part is that now we are reasoning about this by using a view, and then we're analyzing the structure of a folder in this case, using the same mechanism as before. And even more interesting is if we want to focus on one of these. Let's say we are going to this file for Java. I'm selecting the XML. And now within this XML, maybe I'm interested in something. Let's say I know there is a class path. There is a property, there's a tag called class path, and I want to find out what are all the class paths in this system. How do I do that? Okay, I could search, but this is a XML, and because it's a XML, I could parse it. I could parse it using code. However, this view has a button to parse because, that's what you want to do when you have a XML. I could write here some XPath. Maybe I want to show, give me all the class path tags from this. I could run it and I get 8. Super. Or I could even query it from here. If I go to XPath, the file reference has a view that I can use class path to write XQuery, because that's often something that you want to do when you have XML. Super. And now let's write one more view, one more analysis, because here, if we look a bit, we have these targets. And an interesting thing in build is like in the Ant build system is that targets can depend on other targets. So this depends on, prepare. Very interesting would be to create a visualization showing us the dependencies between these targets. And we can do that. I already copied the visualization, so we don't have to write it. So it's this. It's a short one. We use Mondrian, use the tags as edges, and we connect all the dependencies with all the dependent tags. Okay, if we run this, now we get the list of all our dependencies within tags. So these are the main tags. So maybe I select this one, which is test XML. And again, this is live. Test XML depends on init actually. And there are a few other init tasks. But now we are reasoning about the internals of an XML file within the same workflow, where before we were reasoning actually about the structure of XML build files within their folders. Again, we can move as we wish between these kinds of analysis. You don't have to say, now we're doing source code analysis, now we have to analyze a XML file, now we're analyzing a directory or the structure of a directory. It's quite interchangeable. And at the end, to finish, let's just show you one more thing that we can do once we have these analysis in place. As often, let's say we write a query. Let's say that what's very important in our system is that we have graphical components, which we can say are all the classes that are inheriting from Java AWT component. And what's important for us is to know that these deprecated classes, that these graphical components do not call any deprecated classes. It's important for us because we want to make sure that our UI is in a good shape, and we want to make sure that this doesn't happen. Or if it happens, we really want to make sure that we fix it, and it never happens before. We can start with a query. I have the model. We are inspecting the graphical components, which are 195, and then we're writing a query to give us all those graphical components that have as provider type a class annotated with deprecated. So all of them that are calling a deprecated class. So actually we get 9. Not good. What do we do now? We could remove them now or later, but then how do we make sure these things don't appear in the future? That at a certain point in the future, somebody doesn't add another call to a deprecated class from a graphical component. Ideally, to avoid that, what we need and want with help is a test. We'd like to have a test that we can run on our CI, and that will check this. That will tell us, hey, at this point, you have these 9 deprecated, and then if we fix them and we add another one, the test should fail. So we should also test architecture, not just functionality. They are as important. So let's quickly do that. So in GT, we have the notion of an architectural constraint, an architectural report that you can create. And I'm just very quickly going to create one architectural constraint for this. Takes a few minutes. So first, what we need is to create a class that is going to define this constraint. So architectural test, in our case, each is placed within its own dedicated class. And how do we call this? Maybe no deprecated calls from widget classes. Maybe this is the name that I want to give to this class. Then I'm going to need an instance of it. And now this class doesn't exist, so let's create it. And maybe this should be ArgoUML constraint. So choose subclass ArgoUML constraint. Perfect. We created it, and now maybe we can browse it also. So this is the class with the superclass. We can give it model. This is the model on which it should run the constraint. But now, what should it run? So here, what we have to do is we implement the method. So first, let's give it a name. So we have to say a method that tells what's the name of this constraint. For now, I will just take the name of the class. We can save it. And now another method that I want to add is issues. So issues is the method that should be implemented by a constraint to return the entities that are not satisfying this constraint. So here I will just copy the code here. Okay, let's add a temporary. So often like this, you start by playing in prototyping in a playground. And then when you decide, okay, this is what I want, you create a constraint. Super. And now I can inspect the constraint. And I have my constraint. And I can see that, okay, these are the issues that are not matching this constraint. And to be able to actually run it, I need to add it to an architectural report. In this case, I already have an ArgoUML report. If we browse it, this is mostly a class that gathers together a set of constraints. So the build method says, okay, these 3 constraints are part of my model, of my report. So let's add another one, our constraint. which was our new, and let's call model. Okay, let's save. And now we could run the report. And if we run the report to get a view that shows us the constraints and their status. So you can see we have a constraint that says invalid dependencies between UML modules, and this is green. So this means we have no such dependencies, no such invalid dependencies. We have our, which indeed we get the 9 failures. We have also an interesting one. This is deprecated classes with no deprecated clients. So this is just one constraint to get the list of deprecated classes. And what's interesting in that this here, it's a neutral constraint. So if we run this, for example, in Jenkins on Travis, this is not going to fail the build. It's allowed to fail. It's just useful so that we can see, okay, how many deprecated classes are currently used within the system. And actually, this one is quite interesting because for this one, this one is actually quite a more complex constraint, because here we want to check a few dependencies between modules, and then yeah, the way we do that might be more complicated. For the deprecated classes, this was mostly the same as we did before. Okay, so in short, this is what I wanted to show you today. A bit of how you can use this idea of moldable analysis to make sense about your system. Even if your system contains of source code, and you have configuration files, directories, whatever have in a system is data. Then you should be able to analyze it and make sense of it in a uniform way. Otherwise, you just end up having different types of silos, a tool for doing like analysis of source code, another tool for doing analysis of build files, and then this makes this complicates the way that you reason about your software system. Are there questions?
I don't see any questions in the Google Doc, but perhaps people do have questions. Let me start with one. How many different programming languages are supported for building these Moose models?
So there are two types of. There are support for two types of models. So first is the Moose model. So for that, it's, for example, a few Java, C, C++, PHP, I think, Delphi, and a few other of these more exotic models. Fortran, I think, because this was used a lot for making re-engineering legacy systems. And then what there is also in GT, there are a lot of parsers, like the one you saw for Java, that give me the AST. And those are for also JavaScript, I guess, maybe Python, PHP, Swift. There could be, there are more of those.
Those are all built into GT. They can run out of the box, or they have to be loaded.
So they are here and they can run out of the box. If we go here, let's see, maybe there is I don't remember the name, but maybe there is a Swift parser, for example, that I can just use to parse Swift code. There should be a JavaScript, JS parser, maybe. Yes. And we could browse this actually, and this is a subclass of. And now can I browse the hierarchy? So these are the kind of parsers that we have currently for building ASTs. So JS, Java, Antler, software and grammar, CPP, C++, C#, Delphi, Swift, Visual Basic. These are the ones for which we can build the AST. And they all come out of the box. You don't need to install them. And more or less creating a new parser here, it can start from an Antler for grammar. So if there is an Antler for grammar for a language, it's quite straightforward to create a parser for it based on that grammar.
Okay. And as I recall, FAMX just has the basic common object-oriented concepts like methods and classes and inheritance. And if you need more detailed stuff, you have to go into the AST for more complex analyses.
Exactly. So only the high level, and then if you want to build the AST, because most of the analysis, like for dependencies, that code are related to these high-level types. You just care about these small things when you really want to go into details.
Right. And what tools are there if you want to build your own Moose models from existing software projects?
So depends. So if you want to build the SMAC, so if you want to just build a parser, there you have to use SMAC. That's the parser framework, and there you start for Antler grammar that you can then import and parse. So that you can do within GT. For others, so for example, to build a Famix model right now also for C, C++, and Java, there are external, also for PHP, there are external importers that are built on more or less Eclipse on other parsers, like the official parsers of those languages. So there you have to go for now outside, create an importer for that language, for example, in Java, and then create the MSC and import it here.
Good. Do other people have questions? Don't be shy. Now's a good opportunity.
Or it was such a clear presentation, but I doubt it.
So the entire presentation is also available on in a Git repo, which has been shared with you on Piazza. And I also distributed on Piazza the pointer to the 2 blog posts by Andrei, which provide you with more or less the same overview, but in textual form. So you can follow through yourself as well. Does anybody have a question? Okay. It looks like we're done then, Andrei. Thanks very much. I found it very clear, and I hope the students did. Oh, I'll have to post a message. If any of the students, if you're using a Mac, I ran into a problem with the paths. So I'll post a workaround on Piazza. It's a problem with the Mac operating system being very restrictive with applications you install yourself. But there's an easy fix for it. Okay, thanks very much, Andrei.
Thank you.
And have a good day.
You too.